This tutorial deals with, obviously, as the title implies here, this events that are related with the word or. Last time in 7.2 we looked at the three different sort of ways events are related that we look at here. Events related by the word not, or, and then afterwards we look at events related with the word and. So this is this one. I know maybe you already from combinatorics have an idea that it involves addition somehow, right? Somehow it involves addition here. And if you didn't know that, then the fact that one of the outcomes is when do you add probabilities and the other one is developing the addition law, that should give you a big hint that addition is going to be involved somehow here. Whereas if you flip ahead and look at the event A and B, it says when do you multiply probabilities? Well, probably in this tutorial, develop the multiplication law. Okay. With these two situations here illustrate the difference between, not two different situations, one is kind of a special case of another situation. This diagram represents two, a Venn diagram where the two circles do not overlap at all, where knowing that one thing has happened, the other, they can't happen together in this situation. Events A and B, whatever events A and B are here, events A and B can't happen together. This is what the word mutually exclusive means. These two things are mutually exclusive here because they cannot occur simultaneously. They can't both occur. However you want to write that for yourself or say that. Because they cannot both happen together. Be careful with the word together, I guess. Knowing that one event has happened means you know the other event cannot happen. Okay, another way to say it. Knowing A has occurred means B can't occur. And vice versa. Okay, that's what mutually exclusive means. If you think, you can think of a lot of two things. We use the word or in the exclusive sense like that a lot of times. I think the example I gave you before was something like, do you want, would you like fries or salad, right? If you can't choose both of them, as in if there's no overlap there, there's no way of choosing both of them, then things are mutually exclusive, right? Choosing fries means you can't choose salad. Two people running a race, if there's no ties or anything like that, if event A is person A wins and event B is person B wins, if you know that A has won the race, you know that B can't have won the race. This can't occur, right? If Chicago has won the series, Vancouver cannot have won the series. You can't both win the series at the same time. This is what mutually exclusive means. Okay? Knowing one has happened means the other cannot happen. Okay? If it's cards, getting a red card and getting a spade, those are two mutually exclusive things. Okay? Getting a red card, getting a spade, because knowing that you get a red card means you know you can't have gotten a spade, right? Because it's not red, obviously. What are the probabilities here? Probability of A in this case, there's 4 outcomes out of 13, right? So 4 out of 13. B is 3 out of 13. A or B in this case is those two together. Okay? This and this together. Those two together. So what is that number? 7 out of 13? In that case, the relationship between the three of those things, how are those three fractions related? If you know that there's 4 here and there's 3 there and there's no overlap between the two, the two of them together are the or, right? 4 out of 13 plus 3 out of 13 adds up to 7 out of 13. If you know what A or B is, it's got to be the same here as probability of A plus probability of B. I guess I could have written it the other way around, but that's okay to match how it's written here. The problem comes up is when there's an overlap between the two, right? Actually, I guess I should do this third one here. Probability of A and B in this case, what's the chance of them happening together? 0, right? Nothing. This is the kind of the definition of mutually exclusive. The probability of the two of them happening together is 0. Okay? That's a way of knowing if things are mutually exclusive or not. Okay, those are related to each other, right? Mutually exclusive means they can't happen together, or in other words, the probability of both of them, probability of A and B is 0. The other case here is one where there is an overlap. So if this is A and this is B, there's that overlap in the center. That's the AND, okay? That's the AND. In this case, the probability of A and B is not 0. This is why they are not mutually exclusive. This is the situation I think I gave you before, asking somebody, do you play hockey or do you play basketball? It's possible for someone to play both. There is an overlap there, right? You could play only hockey, which means you're in this, okay, in that spot. You could play only basketball, which means you're in that spot. Or you could play both, which means you're there. Or you could play neither one, which means you're out there. All right? If there's a way of them both happening together, it's not mutually exclusive. In other words, you can tell by looking if the probability of A and B is not 0. In this case, it's 1 out of 13. 1 out of 13 outcomes are both events happening together. Okay, so those are tied together. The fact that it's not mutually exclusive goes with the fact that the probability is not 0. So maybe I should even just say that, i.e., probability of A and B is not 0. That's what it's tied to, really. Okay, the fact that it's not 0. That's important to notice. Maybe that's what we should say here. It's not 0, so it's not mutually exclusive. The other ones here you can look at, probability of A is the yellow ones. What is that? 4 out of 13. Probability of B is 5 out of 13. Notice that doesn't mean that probability of A or B is that plus that, 9 out of 13. It's not 9 out of 13. In that case, it's 8 out of 13. Because there's that one in the middle that gets counted twice. Okay? That one in the middle gets counted twice. The shortcut here, or the relationship here, is going to be, if we look at this, it isn't just that probability of A or B. You can't get that just by adding A and B. You need to also think about the overlap here. If I just added A and B, if I just added this and this, how many times have I counted that person in the middle, or that outcome in the middle? When I counted this, right? When I counted this 4 here, I counted those ones. When I counted this 5, I counted those ones. How many times did I count the one in the middle? Twice, right? I counted it twice. So the way the shortcut or the relationship here is, if I just add these two, I know I've counted the overlap twice, so I can subtract the overlap once. If I subtract this A and B, that's the overlap. The overlap's counted twice when I just add those two, so if I subtract it once, I'm okay then, and I get what the A or B is. Alright, so if you look at the numbers, 8 out of 13 comes from taking 4 out of 13, 5 out of 13, minus 1 out of 13. You subtract the overlap once, and you get your A or B. This is a formula that is on your formula sheet, this thing right here. You could write that down. I mean, it's on the next page here, the little box, so maybe you could write something about it there. The general case is what is what I just had up there. To get the A or B, A plus B minus the overlap, A and B. That's a formula just like any other formula. It's, you know, if you had something like X equals Y plus Z minus W, it's a formula like any other one. If you know any three of them, like if you know those three, you can work out the fourth one. But if it's, if you know other ones, if you know these three, you can work out that one, the and, right? It's a formula like any other formula you've had. That one is on your formula sheet. The one below it, the other one that we looked at, was a special case where things are mutually exclusive, where all you have is A plus B. Right? Because this is 0. If you want, you could put a plus 0 there. This is a special case where they're mutually exclusive because that's 0. Right? That's the concept here. I want you to work on some of these problems and we'll come back to them together and look at them momentarily.